In this video, I will discuss energy changes in solution process. Subscribe the channel, watch the video until the end. Energy changes in solution process. Sodium hydroxide dissolved in water to form a solution. When we touch a beaker that contains sodium hydroxide solution, we feel hot. Why we feel hot? I'll answer this question. That when we dissolve ammonium chloride in water to form a solution, and when we touch the glass that contains ammonium chloride solution, we feel cold. Why we feel cold? I'll answer this question again. This solution is the process accompanied by energy change. This solution is the process of forming solution. Formation of solution involves three steps, namely breaking solute-solute interaction, breaking solvent-solvent interaction, and forming solid-solvent interaction. These three interactions must happen during formation of a solution. When we dissolve sodium hydroxide in water, the energy required for step 1 and step 2 less than the energy released in step 3. Therefore, dissolving sodium hydroxide in water is exothermic process, means that it releases heat energy to its surrounding. Therefore, the surrounding gets heat energy and it becomes hotter and hotter. That is why the beaker that contains sodium hydroxide solution feel hot when we touch it. But when we dissolve ammonium chloride in water, the energy required for step 1 and step 2 greater than the energy released in step 3. Therefore, dissolving ammonium chloride in water is endothermic process, means that it absorbs heat energy from surrounding. That's why when we touch the glass that contains ammonium chloride solution, feels cold because it absorbs heat energy from surrounding and the surrounding became colder and colder. When we touch the glass, we feel cold. Attraction and association of molecules of a solid and a solvent to form a solution is called solivation. Attraction and association of molecules of solid and solvent to form a solution is called solivation. Solivation in water is called hydration. Solivation energy is the energy released or absorbed when solid particles are completely surrounded by solvent molecules. Hydration energy is the energy released or absorbed when solid molecules or ions are solvated by water. Heat of a solution, also known as enthalpy of a solution. Enthalpy of a solution is the amount of heat released or absorbed during this solution process. Mathematically, heat of a solution or enthalpy of a solution is equal to mass of a solution times specific heat of a solution times change in temperature. This is a mathematical definition of heat of a solution. Q is heat of a solution, mass M is mass of a solution, C is specific heat of a solution, delta T is change of temperature. Molar heat of a solution of a substance is the heat absorbed or released when 1 mole of substance is dissolved in water at a constant pressure. Mathematically, molar heat of a solution is equal to enthalpy of a solution. You can say heat of a solution upon mole of a solid. This is the mathematical definition of enthalpy of a solution or heat of a solution. Molar heat of a solution, sorry. Molar heat of a solution is equal to heat of a solution upon mole of a solid. For example, when 5.19 gram of sodium carbonate was dissolved in 75 gram of water, the temperature of water rose by 0.8 degrees Celsius. Calculate heat of a solution and molar rate of a solution, take a specific of a solution as 3.82 joule upon gram degree Celsius. Molar mass of sodium carbonate as 105.99 gram per mole. Given one, mass of a solid. The solid here is sodium carbonate and its mass is 5.19 gram. Mass of a solvent is given. The solvent here is water and its mass is 75 gram. And the other given is T final, temperature final, which is equal to 3.8 degrees Celsius. And the other given one is specificity of a solution, which is equal to 3.820 joule upon gram degree Celsius. Formula mass of sodium carbonate, which is equal to 105.99 gram per mole. Required. Calculate heat of a solution. The second required. Calculate molar heat of a solution. Now, solution. The mathematical definition of heat of a solution is equal to mass of a solution times specific heat of a solution times change in temperature. The question here is that how can we calculate mass of a solution? And the second question here is that how can we determine change in temperature? First, let us calculate mass of a solution. Mass of a solution is equal to mass of a solute, which is given, plus mass of a solvent, again, which is given. So mass of a solute is equal to 5.19 gram. Mass of a solvent is equal to 75 gram. Therefore, mass of a solution is equal to 5.19 gram plus 75 gram, which is equal to 80.19 gram. Now let us calculate change in temperature. Change in temperature is equal to T initial minus T final, which is equal to T initial is 0 degrees Celsius and T final is 3.8 degrees Celsius. Therefore, change in temperature is equal to minus 3.8 degree Celsius. Now, calculating heat of a solution or enthalpy of solution, so simple. Heat of a solution is equal to 80.19 gram into minus 3.8 degrees Celsius into 3.82 joule upon gram degrees Celsius. After calculation, heat of a solution is equal to minus 1164 joule. Now, time to calculate molar heat of a solution. Mathematically, molar heat of a solution is equal to enthalpy of a solution or heat of a solution upon mole of a solid. How can we calculate mole of a solid? Let us calculate mole of a solid first. Mole of a solid is equal to given mass upon molar mass. Given mass is 5.19 gram and the molar mass is 105.199 after calculation and is equal to 0.0489 mole. Therefore, molar heat of a solution is equal to negative 1164 joule upon 0.0489 mole. Finally, molar heat of a solution is equal to minus 23,804 joule per mole. I'll come back with another video. Therefore, subscribe the channel. Have a wonderful time. Thank you.